Okay, so we are moving to our next topic, uh, that is inheritance. So before moving to the programming concept or rather programming implementation, let me briefly discuss what inheritance mean, and then we'll gradually enter into the implementation part of this concept. It is basically telling us the reusability of code. What this reusability means that once it is defined under a class, then we can reuse it into same other classes. So how we can reuse it, that I'll discuss in the implementation part in detail. But the topic says that I can reuse the code. How I can reuse. Thing is that suppose some of the members which are already defined under class A. Okay. So this is my class A. I have some member variables, say A and B. Class A, member variables A, B, and then the function fun. These are the members of class A. Okay. So when I am inheriting this class into B, the reusability says that when I'm inheriting the members of class A, the member variables of class A automatically comes to class B. That means A and B both are in class A as well as in class B now, as well as this fun, which I defined under class A, that also available in class B as I inherited I inherit this class B from class A. And the another important thing that I must mention regarding this inheritance, that one thing is reusability. So whatever that we are defining inside class A, that we can reuse in class B. Another important thing is that we can add more in the class B. We can add more means we can introduce new member variable in class B and a new member function also if I want, or as per our requirement. Okay. As per our requirement, we can add more member variables as well as member functions in class B. So what we are doing over here, we are reusing class A. We are reusing class A in class B. That is the main motto of this concept inheritance. Okay, the reusability of code. We can reuse the same code in some other places. And we can add more thing in the class B. So here, as per the example that we consider here, class A is known as the parent class or base class. Okay. And class B is known as the child class. Parent class, or it is known as base class. Class B is known as child class. Okay. Next, I'm moving to the type of inheritance. There are different type of inheritance available in object-oriented programming concept. So let me discuss one by one. So type of inheritance. What are the types? Number one, single level. Number two, multi-level. Okay. Number three, hierarchical. Number four, multiple. Okay. And number five, it is hybrid. Okay. So these are the basic type of inheritance that I am discussing over here. Single level, multi-level, hierarchical, multiple, and hybrid. So how single level inheritance look like? The example that I already demonstrated, that class A and class B, just before this type of inheritance, it is an example of single level inheritance. And if we want to represent this inheritance diagrammatically, it looks like this. Class A, it is class B. So class B is inherited from class A. This means class B is inherited from class A. That means whatever the member variables functions defined under class A, they are all available in class B, and we can add more in class B also. So that is already discussed. Multi-level. So class A, from class A, I am deriving another class, that is class B. And from class B, I am deriving another class, that is class C. So this is multi-level. And when I am representing this within through a diagram, look at the direction of the arrow. The direction of the arrow always from child to parent. Direction representations of the child to parent is representations of the child class and the parent class in a diagram. The direction of arrow should be from child class to parent class, not from the parent to child. So this is a number two type of inheritance, that is multi-level, where class B is derived from class A and class C is derived from class B. Third type of inheritance, that is hierarchical. Hierarchical means that this is my class A. From class A, if I derived two more classes, B and C, just like this. So this is the example of hierarchical. We can derive more than two classes also, B, C, D, E, F. So if the derivation is like a tree-like structure, then it could be represented, or it could be said as a hierarchical type of inheritance. Number four, when we have more than one class, rather more than one parent class, not more than one class, more than one parent class, then that type of inheritance is known as multiple inheritance. So it is multiple. That means class C is derived from class A as well as from class B. Understood? And what is 5? Hybrid. Hybrid inheritance. That means this type of inheritance is the combinations of any two. Suppose this is class A. From class A, we are deriving class B. And from class B, we are deriving class C and class D. So this is single level and this is hierarchical. So combination of single level hierarchical. So that means combinations of more than one type. It is treated as a, or it is known as a hybrid type of inheritance. Okay. So this is the basic theoretical concept regarding inheritance, which we are now trying to implement in our program. So why inheritance is required? This is reusability of code. Keep it in mind. Why we use inheritance? That is the reusability of code. That is the first point. Second point, when we are inheriting one class from other, that means all the data members or other member variables, which I discussed in my earlier lecture, member variables and functions which I have defined in parent class, they automatically comes into the child, and we can add more in the child class. That means we can add more number of member variables as well as member functions in the child class. Okay. So this is the reusability concept that we are incorporating in this concept inheritance. How we can implement this concept in programming, that just I will discuss after this. Next, I talked about the type of inheritance. What type of inheritance I mentioned? One is single level, multi-level, hierarchical, multiple, and hybrid. Okay. So I think this part is clear to you. Now I'm moving to the implementation part. Single level means class B is inherited from class A. Multi-level means class A, class B is inherited from class A, class C is inherited from class B. So this is multi-level. Then hierarchical, from class A, I am deriving two classes, that is B and C. We can derive more than two also. So that is a hierarchical structure, so tree-like structure. Multiple, matlab one single child class have more than one parent class. So here class C have more than one parent class, that is A and B. So this is an example of multiple. Okay. And finally, this is the hybrid type of inheritance where the more than one type of inheritance is concerned. Here, class B is derived from class A. This is single level. And class C, D are derived from class B. This is what type of inheritance? The hierarchical type. So it's a combination of single level and hierarchical. So that's a type of inheritance is known as hybrid inheritance. Okay. So this is the basic fundamentals or basic theoretical part. Then we are moving to the uh, programming implementations of it. So let me move to the programming screen. Just a minute. Let me turn on the spider. Somehow it gets. Yes, just let me share my screen. Okay. So this example I already discussed with you. Moving to the very good example of an inheritance. Look here, I'm defining a class. The name of the class is shape. Okay. What is the name of the class? Shape. Which have only one member, color. You all know it. Initialized as a string. Okay. Then define the constructor. Already discussed how we can define a constructor. Then I'm defining line number 12. It is rectangle. Rectangle. Within bracket, I'm mentioning the shape. This means, in Python, this means this rectangle is my child class and shape is my parent class. And if more than one parent class is concerned, then we have to mention the name of the parent class within this parenthesis separated by comma. Once again, I'm repeating. Look at the syntax. Class, class name, that is my child class name, rectangle. From where it is inherited? From shape. So that's why within bracket I have written shape. What I'm telling if more than one parent class is concerned, we know the concept of multiple inheritance where more than one parent class is concerned. I'm definitely showing you an example of multiple inheritance. So where more than one parent class is concerned, as more than one parent class is concerned, we have to mention the class name, all the class names from where it is inherited, separated by comma. In this place, separated by comma. Introducing two more variables, L and B, along with color. As rectangle is inherited from the shape, that means color member variable is already there. Along with, we are declaring two more members, that is L and B. I think this much is clear to you. Now, I am defining a method, rather a constructor, which is a parameterized constructor. And when I am creating an object of a rectangle, definitely this object must have three member variable. One is color, another one is L and B. L stands for length, B stands for breadth. And that's why I am defining the constructor with three parameters apart from the self. Self, by default, I have to pass. So self dot L equal to L, that means the parameter L. Self dot B, that means current object. Self dot color equal to C. I'm coming to the super keyword just after this discussion. Okay. So that's why I'm commenting this line and uncomment self dot super equal to C. I hope you understood that I am assigning the value of the member variables L, B, and color, as rectangle has three member variables right now as it is inherited from the class shape. Next, calc area. That means it is calculating the area of the rectangle. We all know what is the definitions of it. That is length into breadth. So AR equal to self dot L into self dot B, return AR. And another method I have defined under rect details, that is, which is print the L, B, and color. Okay. And as well as the area method, self dot calc area. Okay. So look what happens over here. What I have discussed in the theoretical discussion time, that we are reusing the code. Shape method already defined. We are inheriting the shape method. We are inheriting the color member, but we need not to declare those color members over here. It is already comes into the rectangle class, as rectangle class is inherited from shape class. Next, another class I am going to create, that is the name of the class is triangle, which is also coming from the shape. So what type of inheritance it is? It's a type of inheritance where class B extends from class A and class C is extends from class B. So definitely it's a type of inheritance categorized as multi-level. And here I'm introducing two more variables. So only color variables is available over here. Along with I'm introducing two more, that is B and H initialized as 0, 0. Okay. After that, what I'm doing, defining the constructor of the triangle method. Definitely it should have three members, color, B and H. It's a parameterized constructor with three members. So I must have to write self dot color equal to C. Okay, self dot color equal to C. Next, calcs area. So 0.5 self dot B to self dot H, half into base into height. We all know the area of a triangle. And finally, uh, inside the triangle details, I'm printing the breadth, height, and the color of the triangle as well. Base height, not breadth, it's a base height and the color of the triangle as well as the area of the triangle. Okay. Created two objects, OB1 and OB2, one for rectangle, one for triangle. Calling the rect details and triangle details because calc area method is being invoked from triangle details and rect details. So that's why we need not to call calc area method separately because automatically it gets invoked as we are invoking the rect details and triangle details. So let me run the code and show you the output what it is giving. First, it is giving 5, 10, and red. Why? Because I am calling rect details method. So rect details method, first line is telling it will print the breadth, height, and color. So definitely it is 5, 10, and red. And then from rect details, calc area method gets invoked and it will calculate the area L and length and breadth, which is giving 50. And in the second call, we are creating an object of the triangle class. Very nice. Passing the parameter green 10, 20. So when I'm calling the triangle details, first it prints the base and height, that is 10, 20, and color is green, and half into base into height, that is calc area method. Calc area method, which is 100. 20 into 10 to 0.5, that is 100. So I hope this program is clear to you. So this way we can implement multi-level. So as we implement multi-level, so already it is in single level already implemented because multi-level is nothing but the extension of the single level. Okay. So we can implement the hierarchical also. Process is same. Child class name, within bracket, I have to write the parent class name. If more than one parent class is concerned, we have to mention all the parent class names separated by comma. Fine. So another example. What this example telling? Class A. Oh, this is an example of uh, multiple inheritance. Multiple inheritance. Absolutely, it's an example of multiple inheritance. What it is telling? Look, class A, which has one member that is x equal to 0. Fine. Constructor, parameterized constructor, taking the value f. One method, that is name of the method is fun, which is non-parameterized, because we already discussed that as is the functions of class member, as a class member. So those function must have one parameter, that is self. So this is self already given. So it is non-parameterized method. I am and printed. I am in class A. Class B, another class, new member y equal to 0. Constructor of class B, parameterized constructor, and it is assigning the value yq. Now I am going to define one class, that is C. When I'm going to define one class C, that is coming from A and B. So it's a type of multiple inheritance. Try to understand. More than one parent is concerned over here. I think my screen is visible. Let me zoom in. So this is the example of multiple inheritance. Class C is extended from class A and B, where a new member is introduced, that is Z. And this is the what? This is the constructor of class C. X, Y, Z, definitely three members will be there, as X and Y. X is coming from class A, Y is coming from class B, and Z is the member which is defined, or rather declared, under the class C. Now I am assigning the PQR to X, Y, Z respectively. Another method which is parameterless fun self. Okay. Now I must mention what is the utility of this super. What is the utility of this super? The utility of the super is it is used to call the parent class method, parent class constructor. Once again, I am telling parent class method, parent class constructor, even parent class member also. Member variable. But to say it is member variable. Okay? So I'm going to define a function, fun, which has two parent class. One is class A, another one is class B. And one interesting thing is, already in class A, we have a function named fun. And as my earlier theoretical concept, this fun is already available in class C, because as and when we are inheriting a class, a child class from a parent class, the members as well as functions all are becoming the member of the child class also. So based on this theoretical concept, we can say that already the fun function is available. Same fun function with same function prototype. Look at the function prototype. This was non-parameterized function or parameterless function. This is a non-parameterized function or a parameterless function. So that non-parameterized or parameterless functions, again, I am redefining under class C. And this concept is known as method overriding. What method overriding says? Function should have same prototype. One is defined in the parent class, other is defined in the child class. Function overloading, I mentioned. Function names are same, but the parameter lists are different. All the functions are defined under same class name. But in case of method overriding, I'm repeatedly telling that it should be function prototype should be same. One is defined under parent class, another one is defined under child class. So here the overriding is implemented, and I'm calling the super to call the parent class function over here. Okay. Then I am printing one line, that is print in class C. So what is the purpose of using super? I already mentioned. The super can be used to call the parent class constructor, parent class method, as well as parent class member variable. So here I'm using the super keyword to call the parent class function. Already I defined the function fun in class A. This has two parent classes. One is class A, another one is class B. Now I'm creating an object of class C, which has three member variable, X, Y, and Z, passing 10, 12, and 15. And in the line number 28, I am creating an object of class A, which has only one member, that is 100. Then I am calling ob1.fun. ob1.fun will definitely call this definition, line number 12, because ob1 is an object of class A. And when I'm calling ob.fun, ob is an object of class C, so definitely this definition gets invoked at line number 24. And finally, I print ob.x, ob.y, and ob.z. That will definitely give us 10, 12, and 15. Let me run the code and show you the output. So first it is showing I am in class A because it is coming for line number 29. 29 is calling basically this method, which is telling I am in class A, Next, ob.fun, that means this part gets executed. So it is calling super.fun. Super.fun matlab it's parent class ka jo fun method hai, that gets invoked. So which one is the fun method of the parent class? This again. So in class A is coming in the output stream once again. Fine. Then print in class C. So that's why it is coming in class C. And finally, it gets printed ob.x, ob.y, and ob.z. So 10, 12, and 15. So hope you can understood how we can implement the multiple instances to this example, and another implementation of the super keyword, which is used to invoke the parent class method. Okay. So another example of multiple inheritance. So look, this is a constructor. This is a constructor. This is another constructor. Okay. And here, second, third. Look very carefully. This is a very important thing I am showing. Example of multiple inheritance, definitely. But another concept I am giving over here. Second is the parent class. Third is another parent class. This is the constructor of the second parent class, constructor of the third parent class, constructor of the fourth. Who is fourth? Fourth is basically a child class which is coming from third and second. I hope you understood. I'm going to define constructor of this class fourth. And inside class fourth, I am calling the what? The init, that means the constructor of the super. Now my question is, which constructor gets invoked? Is it second or is it third? Because we have more than two parent class, rather more than one parent class is concerned. But when I'm calling the super.init, so definitely it will invoke the constructor, but which constructor gets invoked? The order is important. In this case, I have written third and second. So definitely the constructor of third class gets invoked, and you will get the third as an output in your output screen. And finally, this line will come. So let me run the code and show you the output. Look, third is coming. And finally, that's it. If I change the order, then the output also be different. second comma third, second comma third. Let me show you the output. Second. So that is the interesting thing. So super is an example how we can call the member or rather constructor using super. Moving to the previous program where the rectangle and the triangle class, I commented this line super dot init. Let me uncomment the line and comment the self dot color. So what it is doing basically, when I'm calling this constructor, the constructor of the triangle class, it is invoking the constructor of the what? Parent class. Who is the parent class of this triangle? It is shape. So definitely it will call the constructor of the parent class shape and assign the value which I passed as a parameter. P is the parameter used for what purpose? Color. C is the parameter which is used for the purpose color. Let me, first parameter, it is green. Triangle class, first parameter, it is green. So color parameter I pass to the init because the constructor is a parameterized constructor. Parent class, who is the parent class? Shape is the parent class. Go to the constructor of shape, it is a parameterized constructor. So what parameter we are passing over here, that will be assigned to the color member. So we are passing this parameter, okay? Which parameter? The parameter C to the constructor. And remaining two, that is B and H, I am assigning to the member B and H. So by using super, we can call the parent class constructor. Okay. And that constructor can be parameterized also. And we are passing the parameters as a parameter of the init method. Okay. So in this example also we can, comment this line number 18 and uncomment this line also. So I get the same result back. Same result, but using super. Earlier when I discussed this code, I commented the line super. Now it is uncommented and we are getting the same result back. Okay. So this example I already discussed. Yes. You need C, A, B, class A, in class A, A100, self PQR, AB, so PQR gets printed, fund self, super.fund. Super.fund, so it is calling the super class fund method. So again, the same question. No, the fund method is only defined in under class A. So it has already been discussed. 22 discussed. 23, yes. Plus Y, plus Z, plus XYZ. So another example of multiple inheritance. And look, notice one thing that within bracket, in case of Y and Z, object is written. What is meaning of it? The object is written because object is the parent class of all the classes. So that's why we can write object for class Y and Z. I'm in constructor 3, print X, that is Y comma self, Y comma self, init, Z comma self, init. So what it is giving, when I'm trying to call both the constructor, in case of multiple inheritance, I want to call both the constructor in this init method, then I have to follow this line, this syntax. Super y, that is the class name, which parent class constructor I want to invoke, then self, then z self dot init. Okay. So this way I can access both the constructors of both the parent classes and the child classes. So this is the multiple inheritance example. This is also an example of multiple inheritance inside class A, inside class B, inside class B init. So when I'm calling B foo, foo is the parameter. So foo, when it is foo is the parameter is X. So it is calling the superclass constructor B init X, super of B, super of B, super of B, comma self inside class B init. So if I run this code, what is telling? Super B. It is taking the first one. It is taking the first one when I'm writing super B self init X. So it is moving to the inside class A init, inside class A init, as A is the first class name. Okay. If I change the order T comma A, then it is showing inside class C init arg equal to 4. So again, the order is important. This example I already discussed. Another is already discussed. This already discussed. This already discussed. This is a multiple number of arguments to user-defined functions. So thank you all. I hope using this, you can complete your assignment. Thank you.